Hey everyone, this is notes number 20. We could call this unit circle part 3. Okay, so by now you've had a chance to kind of understand where the unit circle comes from. You've had a chance to fill out a blank unit circle, so you should be very familiar with all of these values here. Okay, so how do we pull away from the unit circle and kind of remember all of these values? So I'm going to show you that in the next week here, okay? So starting right now, you're going to try to find out clever ways to kind of remember all of the angles in degrees and radians, as well as all of the ratios or all of the coordinates according to this unit circle here, okay? So the first thing I'll say is this. You want to make sure that when you're given an angle, you know what it is in degrees and in radians, okay? Some things to keep in mind. Remember that when you're looking at an angle in radians, so for instance, if I wrote 7 pi over 6, at the very least, without looking at the unit circle, you should know where we are. And here's what you do. So when you look at this, you notice that the numerator is definitely one more than the other, than the denominator. So the only time you add 1 to your denominator is if you're in the third quadrant. Okay, and that's something that you want to train yourself to do. So you know that 7 pi over 6 is somewhere in the third quadrant. Okay. So for instance, if I gave you 3 pi over 4, think about where you would be, right? So I'm going to go ahead and kind of cover that up for a second, okay? Press play when you think you know where it is without looking at your unit circle, okay? So 3 is definitely 1 less of 4. The only time we do -1 is if we're in quadrant 2, okay? Sometimes that's all you really need to know, like where you are on that unit circle. So if you take a look here, there you have it. 3 pi over 4 is definitely in quadrant 2. So here's another one. What if I told you, let's see. What if I told you 11 pi over 6? Okay. So right here, 11 is, because I've done this before, 11 is definitely twice of 6 minus the 1. This is following the double -1 pattern. So I know that that's definitely in quadrant 4. Okay, that's right over here in quadrant 4. Okay, so you want to kind of visualize that unit circle in your head as much as possible. Okay, and the easiest one, if I gave you like pi over 3, notice how there's no value up here. That pretty much implies that you're in the basic quadrant 1. Right there. Okay? So that's what you're going to train your mind to do. Think about where you are in this unit circle. Quadrant 1, 2, 3, or 4. Okay? So let's practice that a little bit before we move on. So I'm going to list 4 of them for you here. And I want you to figure out where you are. And that's it. So here we go. Part A, B, C, and D. Let's go ahead and figure out what quadrants we're in for the following angles here. Let's do 2 pi over 3, 5 pi over 3, pi over 4, and let's do 7 pi over 4. Okay, figure out these 4 here just in terms of which quadrants they're in. And then press play when you're ready. Okay, 2 pi over 3 is definitely 1 less, so you know you're in quadrant 2. Pi over 4 has no number in the front, so you know you're in quadrant 1. 5 pi over 3, that definitely looks like double -1, so you know you're in quadrant 4 there. And 7 is definitely double -1 as well, so you know you're in quadrant 4. Okay? If you didn't get that, keep practicing, okay? The next big thing is your quadrantal angles. For instance, if you take a look at your unit circle, these are really easy to spot out. Remember, you start off on the positive x-axis. So you should know that when we're at radian 0 or 0 radians, you're on the right. Pi over 2 is up, pi is left, 3 pi over 2 is down, and 2 pi is to the right. Okay? However you want to memorize that. All right? So here's the last task. And this is probably, I want to say, the most challenging part. Okay? You might have to refer to your chart, but what if I presented you an angle in degrees, right? And you're only going to get better at this the more and more aware you are of it. So, for instance, if I told you 150 degrees, okay, where are you? So, obviously, you're in quadrant 3, but here's what you really want to do. Sorry, did I say 3? I meant 2. Okay. You need to know what the radian is. You know, I'll explain to you guys why it's so important to know the radians, okay? I'll give you 2 reasons. Number 1, any upper math after this will use primarily radians anyways. Okay, the second reason you're going to see very soon at the end of this video. Okay, there's a reason why the radians is so much easier. Okay, so in my head, I'm going to show you what I'm thinking. 150 I know is somewhere in the second quadrant, and there are 3 points. I know that 150 is closest to 180, so I know that it's this last point right here. Okay, so I know that that is 6, 4, 3, 3, 4, 6. So I know that this is some version of 6. I know in quadrant 2 I subtract 1, so it's 5 pi over 6. This takes time. Don't worry about getting it like as soon as possible. It takes a little bit of practice. So, you know, we have our unit circle in front of us, but then we slowly pull away from it, okay? So let's try another. Let's say I gave you 225 degrees, okay? Think about where you are and think about which point that is, okay? Press play when you're ready. So I know 225 is definitely surpassing 180 and a little bit less than 270. So I know 225 is somewhere here, okay? Now, the cool thing about these angles, anytime it ends in a 5, you know it's always going to be the middle angle. It's always going to be the middle angle. And the middle ones always have a radian of something over 4. Always, always. Okay? Always, always. So in quadrant 3, I know that I have to add 1. So my radian would be 5 pi over 4. I'm clearly in quadrant 3. Okay, that's what's going on in my head. You know, I'm drawing out the x and y axes for you, but eventually you won't need it, okay, with enough practice. Here's part C. Go ahead and try this one here. Let's do 300 degrees, okay? Really think about this one here. First step is knowing which quadrant, and then the more challenging part is what is it in radians? Press play when you're ready. 300 degrees is definitely something past 270. And remember, we always go counterclockwise. So 300 degrees is somewhere in quadrant 4. Okay? So the thing is, where is 300? 300 is definitely closest to 270. So I know it's this very first point right here. Okay? So in my head, I'm doing 6, 4, 3, 3, 4, 6. 6, 4, 3. 3 will be my denominator there. Okay? In quadrant 4, I know that I double and I minus 1, so this should be 5 pi over 3. Okay? Again, very important and very beneficial when you know what the radian is. All right? Let's do one more just to make sure you have enough practice. Here's part D. Let's do 120 degrees. Okay, think about where you are and what the radian measure is, okay? Press play when you're ready. Okay, at the very least, 120 you should know is somewhere between 90 and 180, okay? So you know we're in quadrant 2, okay? So there are always 3 points in every quadrant. 120 is definitely closer to 90 than it is 180. So I know 120 is definitely right here, okay? So what's that denominator there? So I'm thinking 6, 4, 3. I'm counting in my head, so that would be 3. That would be something pi over 3. If you're in quadrant 2, remember that we subtract 1, so that's 2 pi over 3. Okay? Now, if you're not comfortable, replay this part again one more time and go through it, okay? We're going to move on to this next part here, and this is where the majority of your lesson is going to go. What if I asked you, right, what the sine of something is, right? How would you handle that? So I want you to take a look back at the unit circle. Some of you figured out this pattern before, but I want to kind of highlight that for you. The reason why it's so beneficial to know the radians, okay, is because they all share the same value. For instance, if you take a look at the y coordinates, okay, and remember the y coordinates represent sine and the x coordinate represents cosine, okay? So, for instance, if you take a look at the sine of anything over 6, so, why isn't this working? There we go. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. If you take a look at sine, and I'll highlight it, their values don't change. It's some version of 1/2. Okay? So you're paying attention to the denominator. All right? Now, whether it's positive or negative, you just have to think about what quadrant you're in. So I'm going to give you an example here. So write this down. Let's say I wanted to figure out, and I'm going to go ahead and cover that up. If I want to figure out the sine of 5 pi over 6, okay? In your head, here's what you're thinking. 5 pi over 6, you should know where you are, okay? 5 pi over 6, that's definitely 1 less. So you know you're in quadrant 2, okay? And for sine in quadrant 2, you should know that your answer comes out positive, okay? Sine of anything over 6, you know it's going to come out some version of 1/2. So then your answer is going to be a positive 1/2. So here's the cool thing. All you have to memorize is one ratio. I want you to highlight it, color it, decorate it, however you'd like, okay? As long as you know this one ratio here, you will know everything else, okay? And let me explain what I mean by that, okay? For instance, the sine of anything over 6 will give me a 1/2. That's the 4 little orange dots that you see over here, okay? Now, the only time sine and cosine are relatively the same is at anything over 4. So let me go ahead and get rid of this highlight here. I kind of talked about it in the previous video here. Notice how at pi over 4, it doesn't matter if it's sine or cosine. They both come out to some version of radical 2 over 2. Okay? Now, although the signs may be different, you could tell that it's radical 2 over 2. Okay? So, why am I telling you this? When you take a look at sine of pi over 6, it's a 1/2. If you know if you know that the sine of pi over 6 is 1/2, you should know everything else, okay? So for instance, if I told you that the sine of pi over 6 is 1/2, cosine of pi over 6 is not going to be the same. Notice here, at cosine of pi over 6, it's always going to be different. And if you take a look, there's not a lot of variation. It's either 1/2, rad 2 over 2, or rad 3 over 2. So knowing that at pi over 6, sine is 1/2, cosine has to be the other one. So it has to be rad 3 over 2. Okay? Again, the only time it's going to be the same is if sine and cosine is at some version of pi over 4. That's the only time they're going to be the same. So let me give you another example. So again, as long as you know that the sine of pi over 6 is 1/2. So if I wrote, what's the sine of pi over 3? There's no way that the sine of pi over 3 is going to be the same because sine of pi over 6 is already 1/2. So the sine of pi over 3 has to be the other one. Okay? And if you know that, cosine of pi over 3, notice how they're at both the same angles here, right? So there's no way that they can be the same. So if cosine doesn't come out to rad 3 over 2, it has to come out to 1/2. Okay? It'll take some time to develop. So again, all you have to know is this one angle right here, this one ratio. Okay? If you know this one, you'll know everything else. So let me practice a little bit with you here. So here's part B. I'm going to go ahead and ask you, what is the cosine of 11 pi over 6? Okay? I'm going to verbalize what I'm thinking in my head, okay? So first off, I know that 11 pi over 6 is definitely something in quadrant 4 because it's double minus 1. This is what I'm thinking in my head, okay? So I'm in quadrant 4, somewhere over here. So I know that all students take calculus, so cosine comes out positive. So I know that this is going to be positive something, all right? The only one that I need to know in my mind, I'll draw a little bubble here, bubble. I remember that the sine of pi over 6 is 1/2. Since this is the cosine of something over 6, I know it can't be the same as 1/2. It has to be the other one. It has to be rad 3 over 2. And check it out. Cosine at 11 pi over 6 is rad 3 over 2. Okay? You have the unit circle there to support you, but you slowly want to pull away from it, kind of like how you did with your multiplication tables. Okay? Eventually, you didn't need it anymore. All right? Let's do a couple more. Here's part C. All right. So what if I asked you for the sine of 4 pi over 3? Think about that. Try it on your own without using the unit circle. And then press play when you're ready. Okay, so here's what I'm thinking in my head. I know that 4 pi over 3 is definitely a +1 moment, so I know I'm in quadrant 3. Okay, I know that all students take calculus, so if I'm in quadrant 3, tangent is positive, so I know sine is negative. It's just negative something. So again, in my head, bubble. I remember when Mr. Lee said sine of pi over 6 is 1/2. Okay? This is the sine of something over 3. So I know it can't be 1/2, so it has to be the other one. So it's negative rad 3 over 2. You go to your unit circle, you're going to check, you're going to feel awesome. Sine is the y coordinate. Sine of 4 pi over 3 is negative rad 3 over 2. Okay? Don't worry if you don't see it just yet. It's going to take some time. But let's keep going some more. Here's part D. Okay. So let's say I asked you, what is the cosine of 7 pi over... Let's not do 7 pi. Let's do 5 pi over 4. Okay, really think about that one. Press play when you're ready. Okay, 5 pi over 4 in my head, I know that is definitely a +1, right? We're adding 1, so I know I'm in quadrant 3. And all students take tangent as positive, so I know cosine will come out negative. This is what makes it so easy. Anything over 4 for sine or cosine, I know it's some version of rad 2 over 2. So easy. So check it out. 5 pi over 4. Cosine, which is the x-coordinate, is negative rad 2 over 2. Okay. Here's where it gets a little weird. Here's part E. You really got to think about this one here. Cosine of, let's do 5 pi over 6. Actually, you know what? Let's do 5 pi over 3. Yeah, 3 would be better. Press play when you think you have it or if you're stuck. Okay, in my mind, I know that this is definitely a case of double minus 1. So I know I'm in quadrant 4. And it's all students take calculus C. So I know cosine will be positive, which is what I have here. So I know it's going to be positive. Now, here's my bubble again. Okay, I know that the sine of pi over 6 is 1/2. Okay, which brings me to my next bubble here. So that means I know that the cosine of pi over 6 cannot be the same, right? Since sine of pi over 6 is 1/2, cosine of pi over 6 must be rad 3 over 2, okay? But here's the thing. This is the cosine of something over 3, okay? So there's no way that cosine of pi over 3 is going to come out to something that's radical 3 over 2, so it has to be 1/2. That is probably where it gets the trickiest. Okay? You could think of it the other way too. If you know that the sine of pi over 6 is 1/2, then the sine of pi over 3 is definitely the other one, rad 3 over 2. So that means the cosine of something over 3 definitely has to be the 1/2. Okay? And there you have it. Okay? Here's the last part. I'll wrap this up quickly. Sometimes you might get two things that will kind of trouble you here, okay? You might get quadrantal angles, for instance, like the sine of 180 degrees, okay? 180 degrees is not in any quadrant. Actually, it's left. 180 degrees is right over here. So you think about that point. If I were to plot that point, that's -1, 0. And I know that sine is the y-coordinate, so it comes out to 0. Not that bad at all, okay? So let me give you another one. Cosine of 270 degrees, okay? 270 is definitely down. 270 is down below. So if I were to plot that point, that's definitely 0, -1. And cosine is the x-coordinate because we go in alphabetical order. So cosine is definitely 0. Quadrantal angles are super easy if you just draw out the axes, okay? Now, here's a step even further. What if I gave you the tangent of 270? All right? There's a couple of layers here, okay? Now, 270 we already drew, but I'll draw it out again. I know that this is 0, -1. What you got to do in your mind, or you could write it out, tangent, remember, is sine over cosine. So this is sine of 270 over the cosine of 270. So you think about this point here. Sine is the y-coordinate, so that's -1. Cosine is the x-coordinate, and that's 0. You can't divide by 0, so you know the tangent of 270 is undefined or undefined. All right? Here's one for you to try. Go ahead and try the tangent of 180 without looking at the table, without looking at the unit circle, okay? Just try your best. Press play when you're ready. Tangent of 180, I know 180 is to the left here. So the coordinates there should be -1, 0. Okay, tangent is sine over cosine. And remember, sine is always the y coordinate, so that'll be 0, and cosine is the x coordinate, -1. 0 over -1 is just 0. All right? Okay. Now, what if I gave you something weird, okay? This is the last part. Tangent of, let's say, 7 pi over 4, okay? Not a quadrantal angle. Okay, here's what you have to be thinking. It's the same thing. 7 pi over 4 is definitely an angle that's somewhere in between. I know that this is a case of double minus 1, so I know I'm in quadrant 4. Okay? And if I'm in quadrant 4, all students take calculus. I know that cosine is positive, so tangent should come out negative. So I'm just going to put a negative sign here, okay? But here's the thing. Tangent, in my mind, tangent is sine over cosine. Okay? Sine of something over 4 is easy. That's just rad 2 over 2. Okay? Cosine of something over 4 is just rad 2 over 2. Okay? Now, I already took care of the sine, so you don't have to take care of each sign here, right? So rad 2 over 2 divided by rad 2 over 2, that's easy because it's the same thing divided by the same thing. You're going to be left with -1. Okay? But even if you multiply it by the reciprocal, you'll still get the same thing. Let's do something a little bit weirder, and then we'll end it for the day, okay? Let's say I gave you something like the tangent of, let's see, let's do the tangent of -30 degrees. All right, last example. Okay, this one's a little bit weird because, holy cow, right? We haven't had an angle that's negative. So what do? So remember way back, okay? Whenever you're given an angle that's not in between 0 and 360, you can fix it. We call these coterminal angles. So what you can do here is you can mentally add 360 to it. Since it's too small, we're going to add 360 to it. If your angle is too large, you're going to subtract 360 from it. So here's what's happening graphically. -330 just means that you're going clockwise 30 degrees instead of counterclockwise. But that tends to throw people off. So what you do is you find the coterminal angle. Okay? Tangent, -30 plus 360 is a positive 330 degrees. So 330 degrees is definitely somewhere in quadrant 4. Okay? So you know you're in quadrant 4, so tangent should come out negative because it's all students take calculus. Only cosine is positive there, okay? All right, here's what you do. So 330 is definitely closer to 360 up here. So it's my third point. So in my mind, I'm doing 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. Okay, so I know that this is the tangent of something over 6, specifically 11 pi over 6, but it doesn't matter, okay? Okay. So if you're not good with the mental math, you write it out. Tangent is the same thing as sine of something over 6 all over cosine of something over 6. Think about this here, okay? Remember that we still have a negative. I'm going to bring that down. Okay? And all of this is scratch work, and you guys are encouraged to doing scratch work too. I know, remember in my head, I remember Mr. Lee said the only one I got to remember is sine of pi over 6. Sine of pi over 6 is 1/2. So I know that the sine of 11 pi over 6 is going to be some type of 1/2. Okay? So that means the cosine of something over 6 has to be the other one, rad 3 over 2. So the thing here is you got to clean this up a little bit. How do we divide fractions? First, I'll bring down the negative. we have to multiply by the reciprocal. So you keep that first fraction. Some people call it KFC, but I really hate it. You divide a fraction. That's the same thing as multiplying by its reciprocal. So if I flip the bottom one, that'll become 2 over radical 3. I notice that the 2's will cancel out, and I'm left with negative 1 over radical 3. And remember, if we were to rationalize that, that would be negative radical 3 over 3. There are a lot of layers to this, and that's why we're practicing a lot, okay? Tangent of 11 pi over 6 will be negative rad 3 over 3. Tangent is going to be tough because your unit circle just provides straight up values for sine and cosine. So with tangent, you kind of have to really think about it. Okay? Try your best on delta math. If you get stuck, let me know. All right?